Bismillahirrahmanirrahim. Feb-March 2024, 32 variant and complete paper. We're going to start now. So first of all, he said find the quotient and remainder when this polynomial is divided by this. So first of all, I will copy x squared plus 5 outside. Okay, x to the power 4 minus 3x to the power 3. I copy the whole polynomial here. X squared multiplied what will give you this answer? So naturally x squared. So x squared multiply this, you get an x to the power 4, x squared multiply 5, but it is coming 5x squared. I should not write under it. I should write under this second value. Sign changes is cancel out, and I'm writing in order. First, I'm writing cube, negative 5 plus. I got a plus 4x to the power 2. Now this x squared multiply what will give you this answer? So negative sign will go there, I mean here, and 3 minus 3 into x, or minus 3x, sorry, even multiply with there will get this answer. So negative 3x to the power 3, this multiply with that, it get a negative 15x. I must write under x. Sign changes. Sign changes here, sign changes here. This cancel out. I write 4x to the power before. So plus 15 minus 2. So if we check plus 15, I get a plus 3x. And 27 come from here. So this multiply what? Oh, sorry, I missed the power 2. Yeah, it's power 2. This multiply what to give you this answer? Plus 4. Plus 4 multiply both values. I get 4x squared and 4 5s are 20. So sign changes cancel out, and 3x plus 7 left behind. So he asking quotient. Quotient is the value we get on top. And remainder, which we get 3x plus 7. So I believe student up till here, very, very clear. Okay, so let's try to do next part. Next question, sorry, next part. Find the coefficient of x to the power 2 in the expansion of this 4-mark question. What is the method to do this kind of question? So first of all, I just tell you this is a 4 minus x to the power root is actually half. And this is a binomial expansion, but you know this binomial expansion is applicable only because power is not a whole number. Positive whole number, if we have it, like here, positive 3, positive 4, positive 6, I can apply AS level expansion formula. But whenever fractions come, and especially negative fraction or positive fractions, we are bound to use this formula. 1 plus b to power n, 1 plus product of power with b, and then n into n minus 1 over 2 factorial into square of b. And concentrate, what is the highest power looking for? Square. Just sake of your knowledge, I'm writing the formula n into n minus 1 into n minus 2 divided by 3 factorial. First 2 factorial, now 3 factorial into cube of b. But here in this particular question, we have to use first 3 terms. So let's try to do it. But can I do directly apply a formula? No way. Logic. Actually, this formula only valid if we have here plus 1. We need here plus 1. If we have a positive, even here we have a, for example, negative 1, even here, we can't apply the formula. So there's a very, very important approach. So it means this number, I need 1. So students, I will take 4 common. Look, I show you step by step. I have taken 4 common, 4 gone. So here 1, but 4 is not present with x. So 4 will go in denominator. And we want to test 4 ones of 4. And you can see from here. So students, what is the basic criteria? You can check it 4 into 1, 4 matching, 4 multiply with that, 4 cancel, we get x back. It means what I have taken common, it is a correct. But algebraic rule, if two values are multiplying or dividing in this power, so this power will distribute among multiplying values and dividing. But this is not applicable in plus situation. Some students try to do the same thing, plus and minus. No, in plus and minus, this is not applicable. So because you see this half will go, because what the value sign in the middle of 4 and that multiply. So this half will go on 4 separate, half will go in this bracket separate. And look, I'm writing. Okay, now 4 to power root is a 2, and this 2 I'm writing before. Here I'm eligible to apply the formula. And be careful while applying the formula. You know, students, basic, what is the criteria we have here? So you know it very well. One matching. This full including negative sign is called B, and this is called N. So let's apply 1 plus NB. N means power in that. N is this. B is this. Next is that N into N minus 1. So N is power. So N into N minus 1 over 2 factorial into square of what? Square of second value, but please don't forget negative sign. So 2 times 2x minus 5. And here I'm applying plus into minus x over 8, because 4 2s are 8. And students, for your knowledge, if you type this, only this in calculator, including half. So be careful, half into half minus 1 and divided by 2. It will give us negative 1 over 8. So I'm writing from here, negative 1 over 8. It came from here. And here x square over 16. Lot of chance of algebraic mistakes, so be careful. Here, square of x, square of 4. Okay, student, now I'm just writing it 1 minus x by 8. And this, if you multiply 8 times to 16, is giving 128. So this becomes negative x to the power 2 over 128. So I believe this part is very clear. And now what to do, students? Naturally, we have to multiply them. We'll get our answer, inshallah. Now, what is our main focus? X squared coefficient. I think I can do one thing. This 2 can multiply inside. So I make it easy. This I'm erasing it. I'm writing it now. 4x 2 5s are 10. So 2 multiply inside now. I'm writing terms involving x to power 2. So I will multiply x with a x. So it means this term, if I multiply with this term, I'll get an x. So plus into minus minus 4x and 4, 8 cancel. I've got a half. And x time to x, I get an x squared. Okay, student, this 10 multiply with this. So negative into negative positive, and 10 multiply with that. So 10 divided by 128. It's giving fraction form 5 over 64. And x squared come as it is. And now student, but what he's asking for, x squared coefficient. So I have to type the coefficients, and I get negative 27 over 64 x squared. And what he is asking for, he's asking for x squared coefficient. Okay, so x squared coefficient. So let's see how we can find. It is so simple. Just leave x squared. So negative 27 over 64. And I believe the point is very clear. Okay. And let's go for next part of the question. Next part of question, what is saying here? State the set of the possible values for x for which the expansion is valid. So validity, depends upon, this is have no power, so it's not depending upon that. So actually we have to start from where I think this is I have to start from this step. So when I converted this into one, okay, according to criteria, which is no power, no connection, no dependency on that. It depends upon this part only. So basically, student, this value, whatever we have it here, this one, including negative sign, okay? So negative x over 4 modulus should be less than 1. This is the whole story. I repeat my words. This including negative x by 4 modulus should be less than 1. This is a story we have. And whenever, first of all, 4 multiplies there, so no effect comes like this. Modulus will finish the x, so this clear. Now, if I expand it, students, what will happen? So I think it's okay. We can write directly this answer only, or just sake of your understanding. Whenever we remove the modulus sign, we get what? Less than and bigger than -4. So you write this way, or you write this way. Both are correct answers. Okay. So this shows the validity. So I hope so clear. So this is most probably he write this way answer, but this is also correct. No problem at all. Question number 3. What a question number 3, students, we have. If you look the planning here, question number 3, he given us the complex number. He said find z square. I have two techniques, okay? But one technique, finding the modulus or argument of this, and this is called exponential form. So how to do it? So have a look here. I can do, all right, first of all, do one thing. First, I just make a small sketch, okay? -3, -3. So negative is a positive here, negative. So root 3 is actually, if you check in calculator, 1.7321. So close to 2. So it means this number is -√3. And 1 is somewhere here. So this number he talk about. This is a z, and I'm going to make a triangle. Okay, this is a theta, and this is a modulus. Let's find modulus. What is a modulus, students? Z is equals to modulus is what? So square of that is square of 1. So look, I'm showing you. So square of -3 root and plus square of 1. Actually, iota coefficient. So I got a 3 plus 1, 4 is becoming 2. So z modulus is coming 2. For your knowledge, whenever modulus given, if I take a z square, so it's simply power of this number. Repeat my words. It means if z modulus over whatever, if I want to put z cube, so I will take a cube of this. If power 4 of this. So z square modulus giving us 4. And I believe you got a point. Okay. Now, student, let's go for the theta. How to get theta? Because this is a √3, this is a 1. So tan theta. So tan inverse 1 over √3. Don't take negative sign. And if I type in calculator, this will give you 6 degree or rate pi format. So please convert in calculator in a radian mode, make sure. And when I find the tan inverse, 1 divided by √3, you can type in calculator, is giving you pi by 6. But argument is starting from positive x-axis and move anti-clockwise. So what is the argument, students? So argument of z is pi minus pi by 6. I get a 5 pi by 6. And if I'm looking for, wait a minute, 1 over, yes, correct, okay. Yeah, if I'm looking for what? Argument of z to power 2, students, what is happening here? You know what happens, students? So according to like a law property will multiply. It means it will 2 will multiply with that number. So if multiply with that number, so 2 times 2, 5 pi by 6, it become a 5 pi by 3. So I think you got my point, and 5 pi by 3 is a argument of that. So if you have to convert in this format, so z square and this is going R is called a modulus. So 4 I'm writing here, and iota, this is going in the place of that. So, and 1 minute, please, I will check once again. Yeah, so this is coming what? Iota 5 pi by 3. So ultimately we got it. So student, you observe that how we can get this one, the polar form, okay? So we have done this part even, okay? And let's go for next part. Yes, student, we have because one more thing I just want to discuss with you. When we have crossing the boundary, we have two limitations. We can start from 0 to pi or 0 to negative pi. So we cannot cross the boundary. It's not wrong answer, but we have to convert into the other format. And what is other format, students? If you look at carefully, 5 pi by 3 is what? So it means 5 pi by 3, it is turned to be here. Okay, if you want to know how much this angle left behind, so subtract from 2 pi. Subtract from 2 pi. So 2 pi minus 5 pi by 3. Okay, let me check. 2 minus 5 by 3. It becomes pi by 3. It becomes pi by. So this gap is pi by 3. So this writing style, or you write it here negative, like iota negative pi by 3, and this both are correct. And I give preference to this reason he bound us to give this answer. Hold on, once again, I repeat. I got this pi by 3, but it's a crossing the boundary. If you want to know that, how look, most students getting easy in a degree mode. So if I check it, 5 into 180 over 3. Why I plug in pi as a 180? If you go from here to here, in degree 180, in radians pi. So if you check it carefully, let me type 5 into 180 divided by 360, says 300. So this 300 degrees, that is why you see this becomes 60 degree only. So this is another way to check the value so you can get more confidence. Okay, this is actually 300 pi, 300 degree. And how much left here? 60 degree. That is why I wrote, and why I kept negative sign. You know it very well. When you go anti-clockwise, a positive, and clockwise is always count as a negative. Okay, so this is our first answer completely over, and let's go for next part. Next part is saying here, complex number omega. You say omega or W, no issue. Z square omega is a real. What is real meanings? Okay, for example, I give you an idea. So this is for example, complex number R, or Z complex number Z, 2 plus 3 iota. This is called complex part. This is called real part. If I say that, it means is a 2 along x-axis, 3 along y-axis. But if I say is a real part only, no complex part, so it means this is a no y part. So it means either it has only real part. If he mentioned that, such that Z square omega is a real number only. It means I can say clearly that is a real part. So it has two possibilities. Two possibilities, students. One, if it is origin, it means the point can be here somewhere, or point can be here somewhere. It can be anywhere, okay? I can't say exactly, but it means it is maybe on the angle of 0 or angle of pi, okay? Logic, I just give you again, because he said that this after product, the complex number is a real part. So complex part becomes 0, no, 0 iota. I believe you got my point. So it means this, either we have two options. Okay, and basically we have learned this technique, Z square omega is equals to real. Okay, this is a real, very clear point. So because we talk about this is an angle concerning modulus, I don't know. So I'll try to find modulus angle from here. How to find the argument? So I have to take argument of both sides. So argument of Z to power 2 omega is equals to argument of real has two possibilities. Either it is 0 or it is pi. I have two options. So let's try to take it two options. As I said before, either it could be positive x-axis or it could be on negative x-axis. So I have a two possibilities, students. Okay, let's take one by one. And we have basic concept. Whenever two complex numbers multiplying, we can split them by putting a plus in the middle. Basically, this property behaves like a log. You see, a log property. If a times to b comes, we can split them by putting a plus in the middle. Same property implements on arguments. So that is why I put a plus in the middle. Okay, either it is a 0. Okay, let me write both. One option there and one option here, or pi. Okay, now argument of and I think so argument of he wrote use alpha. You see, the argument of omega is using alpha, so I will use this as a alpha, and even here alpha. Okay, an argument of z square, I just got it, which is minus pi by 3. So minus pi by 3 is my argument. I can use this argument. This is called argument. You know it very well. So this argument, I'm using it here and here. Okay, student, when I bring it on the other end, students, so it will turn to be alpha becomes positive pi by 3. And what about the other side, students? So if I add 1 plus 1 over 3 become 4 by, wait a minute, let me check. 1 plus 1 over 3, it gives 4 by 3. So we got a 2, 4, 5 by 3. But problems coming again here. Let me write it here. But now, if you check it carefully, it is again crossing the limit, because we are bound every time we have to stay in the first two quadrants anti-clockwise, or third, fourth quadrant clockwise. So this is a crossing the limit. How I know? Every time if you want to check it, replace pi by 180 and type in calculator. Because radians sometimes students never understand properly. If I check it, it becomes 240 degree. 240 degrees crossing the boundary. So it is a 240 here. It means, students, if I come the clockwise, so what is turned to be from 3? Okay, it means from what is 360 is a 2 pi. So from 2 pi, subtract pi by 3. Okay, let me check what answer turned to be. So 2 times 2 pi minus 4 into pi divided by 3. I got 2 pi by 3. But you know, when you move anti-clockwise, a positive, and move clockwise, negative. So I am bound to, for this angle, I'm bound to put minus outside. So it means this is coming negative 2 pi by 3. Whereas 240 is a 4 pi by 3. Because these kind of angles, if you don't make it, you can't understand properly. So I believe you got my point, how I got this one, degree mode and radian mode. Okay, so I hope so clear. So I got it, not alpha for this one. I have to, because this is actually anti-clockwise, but it's a crossing the limitation. So I can't take this angle. I am bound to take this angle. Same it happened here. This is crossing the boundary. I have taken the shorter angle. Always argument definition is a shortest angle. So I should write this one, not that one. So I hope so you got the point. So I got because he was asking find alpha, I got 1. Second alpha, I got 1, because he asking two possible values of omega. Okay, student, what left behind? Because you know omega in the form of R. For your knowledge, what is R stand for? R stand for argument. Sorry, R stand for modulus. Alpha stand for argument. Argument, I have it for both particle, both positions. Only what left? Modulus left only. It's not a hard job. It will help from here. So I'm just giving a small pause here. And z to power 2 over omega modulus of both equal to 12. According to modulus property, we can split them. And student, modulus of z square, we just got it on the top. You can see 4. So I can replace here 4. When I replace here 4, students, it turned to be what format? 4 over omega modulus 12. It goes there and comes down. So omega is becoming 1 over 3. So alhamdulillah rabbil alamin, z omega modulus, I got it what? The omega modulus, I got 1 over 3. I hope so, students, this is clear. Now I'm going to write final answer. And omega is equals to what final answer? R is this. What, students? Okay. So is R is this. And e to power I omega, alpha is this. So iota times 2 pi by 3. This is my answer number 1. Second answer, students, I will take same modulus, but argument I will copy this. So e iota and negative 2 pi by 3. Or you can write negative before even, no issue at all. This is my second answer. So you understood, Alhamdulillah, Rabbil Alamin, question is over. But you learn one thing from here, especially we have to go always for shorter angle, okay? Or I have another choice. Rather than finding z, you can find z square first. And how to find z square, students? You just multiply them. I think you got my point, what I'm saying. So multiply them, you get a modulus. And then, sorry, you got a z square, and then you can operate the rest of other things also. So no problem at all. This is a second method is also effective. You can use any one method. Okay, I hope so it's clear. Let's go for next part. Next question, sorry. Question number 4 now we have. In question number 4, he said positive numbers PQ. This is an important point to know. Because logically, what you would have it after logarithm, whenever negative value comes, it gives us infinity or undefined. That is why he said PQ both must be positive. If I put a negative numbers, it will give us infinity. Now he said that this is logarithm given by him, and we need to find this answer. Okay, let's try how we can get it. First of all, I just help you. I just start from here. I have to start from both end. Okay. P to power 7q. If I apply the log property, students, what is log property? Log property is that whenever two values are multiplying in the bracket, we can put a plus in the middle and separate them like this. Okay, same. This applicable log or ln, same thing. So let's apply here. It becomes ln p to power 7 and plus ln q. This power can go down the log property, all of you familiar. So 7 times 2 logarithm of p and ln of q. I stop here. Why? I will get my answer of this only possibility if I have answer of ln p and ln q. Otherwise, I cannot continue. Okay, so let's try to check. Can I get this link from there? So let's start one by one. Logarithm of p by q is equal to small a. I picked from here. Logarithm of q square p equal to b. Okay. This thing available with us. Okay, I think if I look at carefully, hold on, this q. Okay. Can I expand this one? Yes, I can do it. How? ln of p minus ln of q is equals to a. What about this? Same story. Because multiply ln of q to power 2 plus in the middle because they're multiplying. If multiplying, put a plus in the middle. Logarithm of p equal to b. This power 2 can go down because we, you know it, I even applied here even. So 2 can go down, logarithm of q plus logarithm of p equal to b. I am approaching my target. I will solve them simultaneously and get ln p, ln q values. I think it's very clear. I can see clearly that if I ln p cancel out. So why not I just write in order. So this 2 ln q plus ln p equal to p, I copy paste. Upper equation I write in different order. This I'm writing before, later on, before, and this I'm writing later. Or I can do substitution method even. Sign changes, this cancel out. And I got a 2 plus 1, I got a 3 ln q equal to b minus a. Okay, students, so this 3 can go down, and finally I get ln q is equals to b minus a by 3. This value I will replace later on here. Now, what about the other ln p? So same story, student, this value, I'm going to plug in it here or even here. So I plug in this a 2 number, there's a third number. So I put in 2. So when I plug in the whole thing here, what happened, the LNP, okay, minus B minus A by 3 is equals to A. I bring whole thing here. LNP is subject now A plus B minus A by 3. LCM is 3. 3 times 2A plus B minus A. And finally, I get 2A plus B by 3. And these two values I'm going to plug in. And wait a minute. So space problem maybe even. So wait a minute. I copy this here. Okay. And Alhamdulillah Rabbil Alameen. Okay, this value, I'm copying it here. Okay, student, finally, I got this both values. Okay, now I'm put in a one equation. So put in 1. So finally, ln p to power 7 times 2q is equals to, what is that? We have a 7 ln p and that 7 ln p. So 7 ln p. Ln p value is this. So I get what? 2a plus b by 3. And after that, ln q value just add, which is this. LCM is 3. 7 2s are 14a, 7b, and plus b minus a. And finally, I get what? This and this, I get 13. So 13a plus 8b by 3. And if I continue slightly, and let's see what answer I get from here. Hold on, let me check finally. I can split even, students. How I can split 13 by 3a plus 8 by 3b. Okay, or you can leave it even that, other format. This is our required answer. Let me recheck. Yeah. So I hope so. The concept is very, very clear. Okay, and let's go for question number next. Question number 5 we have. On a sketch of Argand diagram, shade the region whose point representing complex number satisfying both inequalities. Both, okay. And student, best technique, make a rough idea and then you make it accurate. This is a circle. How I know when the modulus is one side and second number only is called circle. When modulus on both sides is called perpendicular bisector. And you know, this is, I reshape it, Z negative common 4 plus 2 iota and less than equal to 3. So for your knowledge, this negative sign is a fix. Is a part of formula. This is a part of formula. And this is called center of circle. This is called radius of circle. But you know, very important part. Otherwise, if these kind of questions, when we have we never care about this diagram. So next part is very hard to do it. So that is why sometimes this number can be equal to this or this number, but not here. But there is some connection is there. And what is a connection? I just tell you 4, 2. 4, 2 means, student, this is a region 1, 2, 3, 4, and 2 upwards. So this is center of circle and radius is 3. 100% means it will go 1 unit down and we get a circle. Look, I'll show you once again what I'm going to show. So this is a somehow you understood and this way. Okay. All right. And this is very obvious. This is a 2 gap and this is a 1 gap. We have to be careful of even this thing, because reason, the radius is 3, 3, 3, 3, 3, 3. That is why. Okay, let's start. This is done. Let's about this one. Z modulus is bigger than equal to 10 minus Z this one. So first of all, I will take common from here, negative common. I got Z minus 10. And modulus will finish this negative sign. We get this kind of format. Both are same. And now I'm writing Z negative 0 plus 0 iota. And here I'm writing Z minus 10 plus 0 iota. For your knowledge, what is this? Is 1 point. What is this? Second point. It means approximately, if I tell you 0, 0 and 10, 0. This is a 10, 10, 0. X is 10 and Y is 0. This is 0, 0. So when I draw a perpendicular bisector, it very well. I will focus. First of all, I put compass needle at here. Look, I show once again. If I put needle of compass here, open more than half, I'll get this arc. Put needle of compass here, make a second arc, and it will become like this. And these 2 points, I will join them together like this. And wait a minute, is look like little because I'm doing without any calculation. So this is 100% 5. You ask me how you know, sir, because perpendicular sector of 0 and 10 is 5. So let's try to make them together. So first of all, I will make a circle. Okay, and circle is done, and very clear, and obviously this is a center of circle here. Okay, let me tell you here again. And this unit is total how much? 3 units. How I know? Because radius. But I will divide this in 3 portions, 1, 2, 3. Logic is very clear, 1, 2, and 3. Because if you look at carefully 4, 2, so it means this is a line of x-axis. Okay, and these are 3 units, and common sense, there's 3 radius, but this is a 4. It means 1 unit. What is a gap? Check, please. 1 gap, sorry, 1, 2, 3, and same gap here. So it means this is my second x-axis, y-axis, sorry. And now I'm erasing everything. I think you understood what I have done. It is very clear now, up till now. So you see, it means this gap is this. This gap is 2, how I know? This 2. And this gap is 4, how I know? This 4. And this gap is 3. Out of 3, 2 gone. This is 1. This gap is 1. So this is very important. And one more thing, this is a 1, this is a 3, this is a 3. 3 plus 3, 6 plus 1, 7. So 7, it means I have to drag slightly back. Okay. And 7 and same unit we have here, 3, 7 plus 3, 10. So this number is 10. So this is just approximately, I made it skip because you see the top sketch. Sketch means not accurate, but I will draw even sketch very close to accurate. Actually, this will help you to do the part number next. If you'll not care these things, so next part is very hard to do it. Okay, and normally whenever these kind of questions come, so try your best to do sketching close to accurate. Now, where is perpendicular bisector? This is a 4. How I know? Given here. So 4. This is a 3 gap. If I check it, 1, 2, 3. So this is a 5. So this is coming down, down. So it means here we have a 5. Let me label it here. This is a 5. Okay, now if I draw a perpendicular bisector, although I just show you only, when I put needle of compass here, I drew this arc. You can see the arc. And I put same needle here and make another arc. I believe you understand, inshallah. And now if this arc and this, if I make a scale, take a scale and draw to this one, so it will give me what? It will give me perpendicular bisector. And I make a green color line. So this is a perpendicular bisector. And it's passing through sharp number 5 because it is coming half of 10 and 0. Assume you're not accurate. This gap look like less and this gap look like more. You will not, don't worry, you will not lose marks, okay? Because your main part is you just show this one, okay? All right, so because sketch idea, so that is why. Okay, now shading part. What is shading part? Circle will come in the circle. This is called less than. Less than means shading inside. And what about this, students? Whenever we shade this kind of thing, toward lesser. I repeat my words. Toward lesser. What the point is, we will shade that part. It means this is a 10, this is a 10. I will shade the right part. So don't forget it. I repeat my words. So toward, don't shade towards the more part, toward lesser. So it means I will shade this part. Let me shade it. This is my answer number 1. And 1 minute, student, I just explained to you. Lot of questions maybe on your mind. Anyway, so he said that shade the region which point representing both. This means in the circle, and this means right side toward this point. Okay, and this point is clear. Now, this 4 marks done, students. Now, I will go for part number 2 and wait a minute. I think I will erase this part. This is not required. Okay. All right. Even this is not a part of question. It is, will do for yourself. Now, what to find the greatest value of argument of z? Before I start, what is argument definition? Argument definition is what? Shortest angle with the positive x-axis. Okay, all right. So if I say that, let me share in shaded portion, student, there are many points. Do you think this is a shortest angle? No. Okay. Sorry, not shortest. He said largest. Sorry. Shortest angle means argument stand for the angle with x-axis. Okay, students. But he's asking now, give me the largest argument. Largest, not shortest actually. It's a shorter definition. For example, if I have a point here, so this is a longest, is not acceptable. This is acceptable. This I'm saying shortest. Maybe you understood now what the word shortest comes. It means this is a not right approach. This is a right approach. So this shortest come for the angle measurement style, the way. Okay. But he asking the greatest value of argument of z. So which point make the largest angle? Let's find it. Is this point make a largest angle with x-axis? Not at all. Do you think is this make a largest angle? Not at all. What about this opinion? Not at all. What about here? Not at all. What about this point? No. So this point 100% make a largest angle. So it means in shaded region, which point make a largest? I'll just try to join it. So let's join with a blue color line. And let me take a scale. I am joining that point with this. So student, this is this angle I'm looking for alpha. Okay. Now approach comes, how we get it, this one. So interesting part, if I look at carefully, this gap, okay, I made this triangle. This gap is 5, I know it. Problem, this distance I don't know. Or even this I don't know. I need angle. For angle, I need at least 2 sides. This is I know 5, but I don't know other things. But if you try to approach, you can get it. How come? See, I make it a black color triangle. Inshallah, I believe you understand. Can you see this triangle? Correct. This triangle is a very important triangle. And this gap is what? And this gap is 2. How I know? I showed you before. So this gap is 2, 2, 2, 2, 2. It means this triangle, I make it again. Which triangle? This triangle, I will make separate. Okay, or I do one thing. I take this triangle and make separate. Now, important part, what is this gap? This gap is obviously 1. How I know? Because we done before, this gap is 4. You know it very well. This is a 5. So this gap is 1. So this gap is 1. And now important part. What is this? Radius of circle is 3. So this is a 3. And now, and what is this one? So I can go for this and I can take this triangle down here. Okay, I make this triangle once again because there's a doubling. No problem. You got a point. Okay, so you know in front it is in front of 90 is a hypotenuse, so 3 square 3 square equal to x square plus 1 square. 9 minus 1, I got root of 8. Root of 8. It means, student, this gap is root of 8. You see this red color line, root of 8. And this is 2, 2, already. So this 2. So it means root 8 and plus 2. So it means the full length, I got it here. If I make a big triangle, I believe you're understanding. This is a 5 and this root 8 plus 2. So now, student, this is my target and I think I can find it. So alpha is equal to tan inverse root 8 plus 2 by 5. And please convert in your radian mode. Don't forget it. Tan inverse root 8. Oh, wait a minute. Let me type again. Root 8 plus 2 divided by 5. And my answer is coming with me is 0.768 radians. So I believe the point is very clear. And he was asking greatest angle. Alhamdulillah Rabbil Alameen. I hope so. You got a point. Let's go for next question. Question number next, 6 number. And what a question number 6 we have, he's asking how to differentiate. Okay, students, so have a look how we can do for differentiation. First of all, I just tell you the basic definitions because many students ask me because when I attempt, so they may ask how you got this answer, sir. If I differentiate, for example, x to power 10, what is answer? 10 comes down, power 1, 9 into base derivative with respect to x is 1. But if I differentiating x to y to power 10, so 10 comes down, power become 1 less. No, don't stop it. Now base derivative with respect to x. So dy over dx. So short story, when you're differentiating x, so we write just 1. But when differentiating y, we must write dy over dx. As a teacher, is my experience. Some students miss this dy over dx. So let's try the question. First of all, this one, how to try? 2 will come down, so I get a 4 and power become 1 less into base is y and dy over dx. Now 3x, 3y. I will deal 3x and y I'm separate. U and v. So 3x copy and y derivative come in the bracket and y copy and 3x derivative will come here. So y derivative is coming dy over dx and 3x derivative is coming 3. So I have done this part even. Now x derivative and that 1, sorry, there's a plus 1 equals to, what about x square become 2x. So this is my, 1 minute please, this is disturbing to us. So I believe this part is very clear. But how many dy over dx? We have 2 and I have to make a common. So let's complete dy over dx common out. From these two values, I get 4y and 3x in the bracket. And these two values will go on the right hand side. It will turn to be 2x minus 3y minus 1. This will divide and alhamdulillah Rabbil Alameen proved. And this is alhamdulillah easy. The previous 1 or 2 questions were very hard for students, but alhamdulillah easy came. Okay, student, let's go for next point. What he said, let me recheck once again, 2x minus 3y, yes, correct, okay. Next part, he said that, hence show that curve does not have a tangent that parallel to x-axis. Repeat, show that curves does not have a tangent parallel to x-axis. Before I start, I tell you, a line parallel to x-axis, when a line parallel to x-axis, it has a 0 gradient. And gradient is also called dy over dx. Okay. And when this is y, the y thing, okay? So the gradient is becoming not 0, 1 by 0. It means dy over dx, I have to plug in 1 over 0. So I think clear. Now let's read the question. He's saying, show that curve does not have a tangent and parallel to x-axis. Parallel to x-axis, I must put derivative equals to 0. Before I start, I just tell you, I have to take this equation. First of all, copy from here, paste here. And you know, students, by default, he said that. So I will, he said it should, because this is a d by dx, and by default, it give us the tangent gradient. And we assume that, let's say it is 0. Okay. If I assume, let, although it is not. I assume in a contradiction method, okay? I contradict with that. He said it is not equal to 0, but I say, no, I will take equal to 0, okay? Let's see what I get it here. I plug in 0 here. 2x minus 3y minus 1 over 4y minus plus 3x. This will multiply with that, and I get this over 3x minus 3y minus 1 equals to 0. Okay, now I need an equation, a quadratic equation. So either I make x subject or y subject. But here you see all are almost same, but there are more number of x as compared to y's. So better to make a y subject from here. Or you can make x even, no issue. 3y goes there, 2x minus 1 equal to 3y. Or y is equal to 2x minus 1 over 3. This I plug in top equation, which is here. Let me write 2y square plus 3xy plus x is equal to x square. This I take the master equation from here and I paste here. So put y value here, put y value. And these marks are 3, but anyway, so long algebra, I plug in here and here. Okay, and let's see what I get now. So I have to be careful because a lot of algebra, even here. Okay, this remain as it is, minus x squared come this side. So be careful here. I expanded, and I think you're familiar how to expand. I'm doing directly first term square plus second term square negative 2 into first term second term over 9. 3 cancel, and I got a 2x to power 2 minus x plus x minus x squared equal to 0. X cancel out. So I got 2 multiply inside, I got a 8x to power 2 minus 8x and plus 2 over 9. These two values I solve, a plus x square, I bring on the other side minus x square. 9 can multiply there, and I got ultimately this part. Minus 18x to power 2. Sorry, this is not 2, this is a single x, sorry, this is a single, it's not a 2. Because, hold on, let me erase again. This 2 plus 2 minus 1, I got a plus x squared. So this is only x squared. And I get negative 9x to power 2. This goes there, and I get a 17x to power 2 minus 8x plus 2. And now, you know, student, we done a discriminant style. If you know, is a tangent is there, 100% b squared minus 4ac equal to 0. That apply. A is what? 17. B is what? Minus 8. C is what? 2. So I'm applying B discriminant, and it must come negative. You know, if come positive answer, it means tangent is there. But if this come less than, it means if B squared minus 4AC less than, so it is not touching, no tangent. So I'll have a look now. B squared means negative 8 square for A into C. Here I got 64. And this 17 into 4 into 2 is coming 136 with a negative sign. And I get negative 72. and which is a not positive number, so no real root. It means not, so it proved that. So curve does not have a tangent parallel, okay? So curve does not have a tangent. Curve has no tangent parallel to x-axis. I repeat once again, one more thing. Actually, he said it is, look, this is a curve. This is a tangent parallel to x-axis. It has a zero gradient. He said no possibility. But I said, no, it is possible. If I say possible, I will plug in 0. When I plug in 0, I continue and I end my rules because I got negative answer. It means not possible. We are not getting a real number. If I get a real answer, so it means this equation has some answer. But this equation has no answer, it means this is not possible. And when not possibility, I can say that curve has no tangent. And I believe you got a point very clear. Okay, this question is completely over, and let's go for next question. And next question, number 7, we have, he said diagram shows this curve, its minimum point is M. Minimum point is M, and X value at that is alpha. Alpha satisfies this expression, I have to prove it. How to do it? And we got a hint here, and that is a minimum point. It means at minimum point, all of you familiar, derivative must be 0. So how I can do it? So let's try to approach. So first of all, dy over dx. Here product rule, first function copy second derivative, second function copy into first derivative. So this is copying, so this derivative comes here. First e to power 2x into 2, I'm writing here. Now this copy and x derivative is coming 1, and this become minus 5. And I'm putting derivative 0 logically, and two things important. I just tell you what I will put here 2 parts. Put derivative is equal to 0, and we put x is equal to alpha, because he said that at alpha it has a no point of minimum. So I will plug in 0 and each x replaced by alpha. So I believe you got the point. Okay, and this is my target to approach. If you're getting issues, you can do reverse process from here. Okay, 2 multiplies there. I got 2 alpha is equal to logarithm of 5 over 1 plus 2 alpha. Okay, students, whenever you want to cancel, because there's a no logarithm. If you want to cancel the logarithm, let me write again a little bigger so you can understand. This I'm copying. Alpha is equals to 1 over 2 logarithm of 5 over 1 plus 2 alpha. This multiplies there. I got 2 alpha equal to logarithm of 5 plus 2 alpha. If I want to cancel logarithm, I need logarithm here. Students, I can write 5 like a 5 into 1. And 1 we can write logarithm of e, and this power go in the power. If you type, student, ln e to power 5, it will give you 5. So if this will give you 5, same thing. So can I write this also? Logarithm e to power 2 alpha. And this writing style same. No problem at all. Log cancel. I'm approaching here, and I think I should stop here now. Although this is not my target, but I think I can reach my target now. Is this matching? Yes. So make it alone, and rest value will go on the other side. So best technique, what I will do, I will bring, because 5 is positive, so I will bring 5 on the other side. And from these two values, x e to power 2 alpha common, I got 2 alpha from here, and from here plus 1. Or write the same order what he writes. This will go under 5. Ultimately, I got 5 over 1 plus 2 alpha e to power 2. So I approach the same. Now from here, you write backwards. You got to prove, inshallah. Take, first of all, I'll switch the sides. When you switch the side, no sign changes. Take a logarithm of both sides. This will come down, and ln is 1. So this is done, but is it not target achieved? One more step is left behind. This 2 will come under it, and alhamdulillah rabbil alameen. Proved. Okay, and check it. Yeah, same. He said verification, how we can do it, students. Two options, either this go right side or this whole thing come left side. You both are okay. I think I should bring alpha on the other side. So f of alpha equals to half logarithm 5 over 1 plus 2 alpha minus alpha. Student, he said, use your calculation. By calculation, plug in these numbers and check, is this root lies between these two numbers or not? And what is the method I explained in my previous lectures many times? And I repeat again here, I will plug in. I will plug in. Okay, let me write even here. Oh, 0.5. Now, student, I'm typing, here's no sine cos involved, so no problem. Otherwise, we have to be careful radian mode. So 5 over 1 plus 2 times 2.4 and minus 0.4. My answer number one is positive 0.111. And let me check the other one if I plug in 0.5. This answer is coming with me negative 0.0419. You know, students, as sign changes, you see, I write a statement as sign changes. So root lies between 0.4 and 0.5. And I given this example many times, and I give again. Basically, first value is positive and later negative. So this kind of curve, and point list is, let's say, 0.4, and my y value is a positive, and this value is 0.5, and my y value is negative. You see, one positive, one negative. And this point where it intersect the x-axis, this is called root. It means you learned one lesson when if let's say not intersecting x-axis, it has no root. I believe you got a point very clear. Let's go for last part of this question. Use iterative formula based in part 1a and alpha to 2 dp, give each answer 4 dp. So part 1. Now part 1, this I will take it, and hold on, let me check. Yeah, it's proved here. I will take this whole expression. Okay. Copy from here, and I will paste here. Okay, reshape it. 1, 5 plus 1 plus, so 5 over 1 plus 2 alpha. Student, what is the technique here? Rule is what? Left-hand side, whatever variable, right in the bottom, in the base is the n plus 1. It's called subscript. Here alpha, I will write n here. Make sure here n plus 1, here only n. Okay. All right. Now we have to plug in every n by 1, even here and here. So I get what? Alpha, I'm writing here alpha 2, y2, 1 plus 1, 2. And 1 plus 2 and alpha, plug in here, alpha 1. Interesting, alpha 1 is called initial value. Sometime a given initial value, sometime not given. When not given, we know the root lies between these two numbers. I will take average of these two numbers. So 0.4 plus 0.5 divided by 2. Alpha 1 is giving 0.45. This will come in the place of here. So I'm erasing it now here, and I'm writing 0.45. And let's try to find alpha 2. This is alpha 1 I have already. Alpha 2, I'm getting what? Let me check in my calculator, students. Okay. Okay, 2 times 2.45. And let me check. Yes. It is becoming, students, 0.4838. First I plug in N1, student. Now I'll plug in N2. If I plug in 2 here, 2 plus 1, 3, alpha 3. Half times 2. Logarithm 5 over 1 plus 2. When I plug in 2 here, alpha 2 is this. So this whole value will go here with 2 multiplying. Okay, student, let me check what answer comes with me. 0.4663. Okay, continue. Further more values, n is equal to 3 here, 3 here. I got alpha 4 is equals to 1 over 2 logarithm 5 over 1 plus 2, and alpha 3 means this value will go up there. So times to 0.4663, and let's see alpha 4 is what? My answer number is this 4753. Now, up till now, the numbers are not repeating. They are so different from each other. Not so different, but some difference is still there. I will try with the 4. Alpha 5 is 1 over 2 logarithm of 5 over 1 plus 2 times 2. This value is coming it here now. So 0.4753 gives alpha 5. And let me check 0.4707. Now, students, see, start matching now. It start matching. Okay, 2DP matching. Okay, but I'm not sure what happened, the nature of the third digit. So for that reason, I check one more time. One more time, because I have to confirm it. Alpha 6 is 1 over 2 logarithm 5 over 1 plus 2 times 2, 4707, and alpha 6 I'm getting is 0.4730. Now, students, see this number is no more changing, and 47, yeah, it is. So means our answer is coming 0.47. So alhamdulillah rabbil alameen. I hope so the concept is clear, and let's go for next question. Question number 8. Express this in the form of this. So first of all, we have to expand this. So let's try. Cos x plus pi by 4. So fundamental law what? Cos x, cos pi by 4, opposite sign of it. And I can write here sine x and sine pi by 4. And you must aware that cos pi by 4 and sine pi by 4, please convert in radian mode, and this both give you root 2 by 2. Okay, now this is my answer of first part. Now you can see outside is multiplying. I can keep the values now full. 3 sine x plus 2 root 2 cos x plus pi by 4. This I'm copying only. 2 root 2 in the bracket. This value come from here. So cos x root 2 by 2 sine x root 2 by 2. When this value multiply with the both, so what happens then? 3 sine x. When it's multiply root into root, first of all, this 2 will cancel with those 2. Root 2 into root 2. Look, I show here. Root a times 2 root a. Give you a only. Same way, root 2 into root 2 will give you 2. So this is coming, this is cancel out. And root 2 into root 2 cos x. Same way, this root and root, just a minute. Okay, root 2 into root 2 is 2. So that is one. Same approach here. Root 2 into root 2 become again 2, and this 2 and this 2 cancel. So student, this is a, now you can write this and this together, and I got only sine x plus 2 cos x. And now I think this partially, this part is over. Now, you know, this whole thing equal to that. So I'm going to copy this whole thing equal to this. This becomes sin x plus 2 cos x is equals to what? R form. If I expand the fundamental law of sine, so what is sine formula? Sin x cos alpha, then same sign, then cos alpha, cos x into sin alpha. But R is multiplying outside. You can see this is I replace here. So can I multiply R inside with the both values? Why not? So R comes here and R comes here. I hope so you understood, student, how I got it. I expand this one. I have expanded, copied here, and there's a whole thing, you know it very well. Now I'm using a comparison method. When I compare both sides, so from here, sin x cancel out. What is here? R cos alpha equal to nothing here. Nothing means 1. So I can say here, R cos alpha is equal to 1, equation number 1. Same way in this part, what is common thing? Cos x cancel. So R sin alpha is equal to 2. Equation number 2. You know, basically, students, because we know sine square plus cos square is 1. So if I square the equation 1, I square equation number 2 and add them. So when I get left-hand side, I will get left-hand side square of this and square of this. R square sine square alpha and R square cos square alpha equal to square of this, square of this. And ultimately, I get right-hand side is 5. But here, what is common? R square common. What left in the bracket? Sine square plus cos square. That is what 1. And 1 into R square become R square. Take a root of both sides. We got a plus and minus 5. Keep I here. R is bigger than 0. So it means we take a positive. Be careful. Sometimes you can say negative even. Okay. This done. This R value you can plug in here or here. Okay, I put in 1. So 5 and root 5, sorry, not 5, because I power root. So root 5 cos alpha is equal to 1. So alpha is equal to cos inverse 1 over root 5. Okay, students, let me convert. Okay, get the answer 1 divided by root 5. It is giving me alpha is become, he said 3 decimal places. So it means I got a 1.107 radians. So finally, what he was asking us this. This full I have here. So I copy the whole thing and I paste here is equals to R form. R form means R sine x plus alpha. R is root 5, then sine and x plus alpha. And I believe the point is very clear. We have done it. Alhamdulillah Rabbil Alameen. Okay. So, yes, 1.107. Okay, over. Let's go next question. Most probably when we have a R form, this is called R form. When we have finished R form, utilize the next part. So let's try to look here how we can do it. Is this matching fully? Not at all. I will take 2 common from here. I got 3 sine half theta plus 2 root 2 cos half theta plus pi by 4 equals to 3. This 2 will go under 3. and we get 3/2. And check it. Interesting part. Look at on the top. If this x, so this x. If this k, so here must be k. One more thing. If I say this is a 2, for example, 2 theta, this is a 2 theta, then this must be 2 theta. So same story. If this is half theta, check it, half theta. So I will replace whole thing same, just only one difference, this is half theta. So I'm getting here √5 sine half theta plus 1.107. This I got from here. Okay, only replacement of x with this one. After this, √5 will divide. So when it divides this way, so we get what sine? We get a sine half theta plus 1.107 equal to 3/2 √5. This √5 came down. Okay, students. Now, I will take this whole as a principal angle, full bracket. I will counter the principal angle. Sine will go there. So 3/2 √5. So when I take a sine inverse in a fraction 3/2 √5, it giving me alpha is coming 0.735. It means sine is positive where? Sine is positive. Positive is in this quadrant and in this quadrant. First of all, so 4 pi, we have to go anti-clockwise. Okay, anti-clock. And same way, this is a 2 pi. This again 2 pi. This is 4 pi. And if I go, this was going this way. You agreed, but this is going backwards. Okay, this is 0.2. This is coming what? -4 pi. So it means we have to look upon double rounds. Okay, so let's start. But we have to keep our eye in these two blue lines. So first answer, if you look at look at carefully, what the first answer is going to come. First, this one, 0.735 and 0.735. Now let's start from positive x-axis and move anti-clockwise and clockwise. And bring back this angle back here. I'm writing this half theta plus 1.107 is equals to, first answer, let's talk about anti-clockwise, okay? So we go for 2 rounds. Answer number 1 is this. I'm writing, I show you 4 options. So this is a line number 1, line number 2, line number 3, and line number 4. So first answer is this. Second answer is this. Then third answer is 2 pi and plus this. And this 2 pi plus this. So first of all, this answer I write directly. So 0.735. This done. What about the second one? Because this is, 0.73. So what is from here to here? It's called a pi minus 0.735. And what about the other one? In this, these we have 2 answers. And best technique, because when you say 2 pi plus that short story, in these both answers, I will add 2 pi, 2 pi. 2 pi plus 0.735 and 2 pi plus the other one answer. Now, student, this is what I will do. I will subtract this value from here, subtract here, subtract here, subtract here. And after subtracting, I will multiply this half. So when this 2 will go there, it multiplies. So let's do one answer. So first of all, I'm doing this and this subtract. So I'm saying 1.107 minus, sorry, 0.735, 735 minus 1.107. And whatever answer comes into 2. So my first answer is I'm getting negative 0.744. Repeat, this will subtract from this number and 2 multiplies after that. And pi minus 0.735 and minus 1.107 and the whole thing into 2. And I'm getting answer 2.599. Let me check 1 dp or 2 dp. He not mention. And he radians. In radian, always 3 SF. So 29 you say, or 260, no problem at all. So I can take it here 2. Because radian always 3 SF. So I write it here 59 becomes 60. Okay, third answer. So this value will subtract from here and into 2. So 2 pi plus 0.735 minus 1.107 and into 2. I'm getting 11.8. Again, it is a 3 SF. Okay. Last value, this one. So subtract this into 2. So it becomes 3 pi minus 0.735 minus 1.107 and whole answer into 2. My answer is coming 15.2. Make sure we have to keep in 4 pi. What is a 4 pi actually? If you check it, 4 pi value, it is coming equals to 12.6. Keep in your eye 12.6. So this is out. And these 3 are in range. Okay. So now first I talk about anti-clockwise. Now I go clockwise. And you agreed that I will look at here. This one part is over. Now again, I make it 4 crosses. Wait a minute. Alhamdulillah. So I will make here 1 cross, 2nd cross, 3rd, 4. Blue lines will not change. This remains same. Here, 2nd, 3rd. Okay. So first answer from here, I'll show you black color. This is my first answer. This is my second answer. Okay, now rotate 2 pi and stop it here. Again, this 2 pi and stop here. And all answers, how to find it, not a hard to know. And every angle, you know, 0.735. So let's try to do it. First of all, I bring back this again down. So half theta plus 1.107 equals to what? So let's talk about this. You know, student, this is obviously is clear. This is a 0.735. So what is this? 2 pi minus that, but I put a negative sign. Look, 2 pi minus 0.735, but I will put negative sign outside. Negative for anti-clockwise, and I believe this part is very clear. Okay, so let's proceed. So next answer is what? This from here to here is what? So naturally, this angle, you know, 0.735. So pi plus that. So I write pi plus. So pi plus 0.735, but I put negative for anti-clockwise. What about this? So basically what answers we have, okay, I can show you this one. This answer I have already, right? Or maybe some confusion for you. I tell you that easily. What is from here till here? Negative 2 pi. What is here? Negative 4 pi. So from negative 4 pi, or I just count negative, I keep outside. Better. What is, if I leave the negative sign, what is this 2 pi? What is this 2 pi? 4 pi. From the subtract, I can say 4 pi minus 0.735, and outside I'm writing negative sign. And I believe you got a point. Okay. Same way, same we will go for the one more part. Okay. And let's see how we can last part. I mean to say this one. And what is this is 2 pi. What is this? 3 pi. And what is this angle? You know it. Okay. So I can say here 3 pi. Look, I'm writing here. Okay. I'm writing here 3 pi and plus 0.735 and outside minus. Now, students, I will calculate all these angles. What is way of calculating? Type this in calculator, minus this into 2. Okay. So best idea, because I'm following an easy way, I can do another way even, but that may be some confusion for you. Okay. So, okay. And my first answer is coming with me is negative 13. And let me write it here. Negative 13.3. Okay. Then next one is our next answer, and this is naturally crossing the boundary. Okay, negative 4 pi even, so negative 12.6. So this is crossing out. And what about this? I will type and this subtract, and then I will into 2. So best idea, type as it is, so chance of mistake will reduce automatically. And negative 1.107 and into 2. My answer is coming negative 9.97. What about this third one? Same, I will type it. Negative in the bracket 4 pi minus 0.735 and negative 1.107 and whole thing into 2. There's also negative 25.9, which is out. Last one. In the bracket, or wait a minute, 3 pi plus 0.735 and negative 1.107 and into 2 is also becoming negative 22.5, is also out. So we have 4 answers, which I'm writing finally. Smallest answer I'm writing is negative 9.97. Okay. And then what? And well, hold on just a minute, please. Yeah, this is alpha is something previous. This part is separate. Okay. And second, this I copied, and then I will copy this one. And second smallest angle, negative 0.744. And then after that, I will copy this 2 values, 2.6, 2.60, and after we have a 11.8. So alhamdulillah rabbil alameen, I believe the point is very clear, and we got 4 answers. And let's go for next question. Next question, he is saying here that all these position vectors of A, B, C are mentioned. Okay, and show that is a rectangle. And in rectangle, I have a plan here. O, A, B, C. All right. How to prove it? Rectangle, this is a 90 degree. You know it, all are 90 degrees. So students, what is the method? You know it very well. 90 degree means scalar product. You know, I will use scalar product. And scalar product formula is what? So in this particular condition, I will use two vectors. This is OA and this is OC. So let's see the formula. I'm going to show you formula is what? OA dot OC equal to OA magnitude into OC magnitude into cos of the angle between them. And OA dot OC magnitude of 1 magnitude of second into cos of angle between them. Or, you know, it's very well, if the dot product come equal to 0. So it give us the, for example, there are three situations. Even I typed, for example, if this comes 0 answer, imagine. So this will divide and this will remain 0 and cos inverse, it give us 90 degree. So no need to apply full long formula. Basically, you have three criterias. If theta is a 90 degree, then the product of OA dot OC, let me write in a proper way, OA dot OC is equals to 0. And if theta comes less than 90 degree, then OA dot OC is positive answer. And if theta is bigger than obtuse, then OA dot OC must be negative. So no need to work out full that we have to prove that angle theta is 90 degrees. So if we get a dot product, if this comes 0, answer is proved. So let's try to find it. OA is a 5, negative 2, 1, and OC is 3, 4, minus 7. I choose from here, I choose from here. Okay, let's see. 3 5s are 15. What is basic criteria? Corresponding position values always multiply. 15 minus 8 and minus 7. You see 15 minus 15, it becomes 0. Hence prove that so theta is confirmed 90 degree, and it's 90 degrees show this orbital rectangle. So this is not enough, because sometime, for example, I give an idea. This is diagram, this can be a different diagram even. So this is 90 degree, but we need one more 90 degree. One more 90 degree, okay? And what is method of doing that? So this is a prove 90 degree, but I have to prove one more 90 degree. For example, let's take a OC, OA taken. Now I'm going for OB, OAN, and AB. And for your knowledge, AB and OC are same, because we have to show that OABC is a is a rectangle. And angle 90 degree, although we have another thing even, if all angles are 90 degree, this is a one proof, one definition, okay? And second one, all lengths are opposite lengths are equals to each other, okay? There's a rule of the rectangle. So one angle 90 we proved, okay? And now I think we can go for another angle, and this is 90 degree. We we can prove because basically, if we go for this angle 90 degree, what is method to prove it? OA and AB. So first of all, I need AB. And AB, so so I'm going to find AB now. What is method, students? OB minus OA, you know it very well. OB minus OA will give me AB length. Okay. What is a OB? You know, it's very clear. 8, 2, minus 6. OA is a 5, negative 1. So if we subtract, I got a 3, I got a 4, and I got negative 7. So I got it AB, which is luckily resembles with the OC. You can see, students, it means the vector OC and not even the value is also matching. So we say that magnitude of the OC are equals to each other. Now let's go for OA. We have already. I'm looking for CB now. CB. So let's try to find CB vector. So CB vector, how to find? OB minus OC. So one vector, second vector, here answer. OB I'll get from here. 8 to -6. OC is 3, 4, -7. Okay. And now 8 minus 3 gives us 5. Here -2, and here I get a 1, which is resemble with this one with the OA. So I can say from here as clear that AB vector, length of AB vector is equals to what is, because vector is totally matching. AB vector is matching with the OC. Okay, and AC and CB vector magnitude is actually, you can see CB, this is CB equal to OA. And no need to find magnitude because vectors is matching, even signs are matching. You see, it's totally matching. If this is totally matching, so there's enough evidence to show. All right, and even you find the magnitude, even no issue at all. And when all lengths are like opposite lengths are equals to each other, it can happen in a parallelogram even. So then angle is not 90 degree. But if I proved one angle 90 degree only, and these lengths are equals to each other, there's enough evidence for proving that this is a rectangle. Hence, we can say that, hence, OABCD is a rectangle. Or just, I think idea is very clear, because no need to, it is matching, you see. If the matching, you find the magnitude, they become equal to each other. So this is okay. Now he's saying find the angle between the diagonals of OABC. So let's see how we can find the angle between the diagonals of OABC. So, okay, first of all, I'll make a diagram. O, A, B, C. This is diagonal number 1. And this is diagonal number 2. Okay. So let's see how we can find it. What is method? I have to find this angle. Okay. Or acute angle he asking, so I did not take the other one. Even if I find this one, then I subtract from 180. Okay. How to find this angle, students? So if you concentrate, this line, this vector is what? This arrow. This is called starting from O, ending at B. So this arrow, red color, is OB. And what about this vector, student? This. How to pronounce this? Starting from C, ending at A. Okay. Basically, what is the criteria? So whenever we need an angle to find, we must meet the tails of each vector to meet each other. So this tail OB, if I drag, like I show you, look, this is, or I show in a black color, so you can realize easily. This is OB, and it is hard to show you, but anyway, I try now. Okay. And if I drag, you see this dragging and bring it here. So vector will not change. Okay. Same way, students, I have a, for example, I have this vector. Wait a minute. This vector. If I drag slightly here and bring tails together, so our answer is not affected. So this is O, it is a O meeting and C meeting together. But this is a B, OB, and this is a CA. I think this angle is that I think point is very clear. So what is the basic plan? Basic plan is CB vector and OA vector. So I'm writing CB vector dot OA vector is equals to magnitude of CB into magnitude of OA into cos of angle between them. Let's see CB we have or not. Yes, we have CB. So 5 negative 5 minus 2 and 1. And what is OA, students? OA is 5 minus 2 and 1. 5 minus 2 and 1. Let me check. 5 minus 2 and 1. Hold on once again, I check it. Oh, I don't need, oh, I need, no. I need CB and OB, sorry. This, I need OB. This is OB, students, make sure. OB. Check again. C, yeah, I took actually wrong values. That is why I'm little. So CA and OB. Yeah, this was a mistake. CA is this and OB is this. Now correct. CA and OB. So let's try to find the values. OB is obviously we know it. And the 8, 2 minus 6. 8, 2 minus 6. 8, 2 minus 6. And what is CA? CA is basically, oh yeah, we can find it. Okay, I'm finding here. CA vector, how to find OA minus OC. OA minus OC, and here we have answer. And OA is what? 5 minus 2, 1. And OC is what? 3, 4 minus 7. 5 minus 3, I get 2. And here negative 6, and here I get an 8. This whole thing I shift on the next page. Even I write it here. Okay, and this is a part of question. This is a part of question, or it means I paste here. Okay, and then I do this whole process under it. Okay, so this is value come from there to negative 6 and 8. And magnitude of this is what? Is nothing hard, square of each value and add them. 4, 36, and 64. And what is the other one? 64 plus 4 plus 36 into angle between them. Corresponding multiply 2 at a 16, 6 to the 12, and minus 48. So 16 minus 12 minus 48, I get negative 44. And if you check it, this one, this is becoming 100, 104. So this come root of 104 is also coming root of 104. And this both, when and if they multiply, you know, root 3 into root 3, you can check in calculator, it'll give you 3 only. So root 4 into root 4, 104, this answer. Now I take a cos inverse, and cos inverse 44, negative 44 over 104. But you know, I just said you it will give you in what? Because negative sign I discussed in detail the previous part here. If this dot product is negative, we must get obtuse. If positive, then less than. If equal to 0 is 90 degree. So it means obviously it is now clear. It will give us obtuse angle, but you know we'll subtract. I got 115.0 degree, but it's a acute angle. So 180 minus this, we get answer 64.97. And if we round it it gives us 65 degree. Okay, students, I hope so. The point is very clear. All right, okay. And let's go for next question. Next question, number 10. He's saying here A is a positive constant. It means if I take a negative, I will eliminate. If I get a negative, I will eliminate. So he's saying partial fraction of it. And what is method? We always do this question by a special technique. So I'm writing now here 2a plus x and 2a minus x and 5a minus 2x. Equal to a plus b and plus c. And we write first factor 2a plus x here, 2a minus x here, 5a minus 2x here. Okay, so this is very clear. Now I will multiply. LCM is a little harder for you. If you multiply with the whole fraction with the left-hand side denominator, multiply by 2a plus x and 2a minus x. I mean left-hand side denominator, which I have here. I will multiply. When I multiply whole expression with that, this will cancel completely. And I will get what? I will get this alone. So I'm writing here 36a squared. When I multiply this whole factor with that, so this cancel with that, so these two will stay beside of a. So 2a minus x times 5a minus 2x. So when I multiply with this, so middle part is cancel, this one and this matching, they will cancel this one and this will stay beside of b. And I'm writing 2a plus x times 5a minus 2x. Okay, this part is very clear. Now last part, when this multiply with this factor, this will cancel out, these two values will stay beside of c. This is easy, this is actually LCM, okay? All right. After this, what I will do, students, I will plug in this part equal to 0. So x value become negative 2a. I'm going to replace every x by 2a, negative 2a. And when I plug in, let's see what happened, 36a squared on the left-hand side, still same. When I plug in this here, okay, and let me check because I said that positive part, you see, matching this 0. So you see this matching this 0. So it means this part will finish, this part will finish, but it will stay behind. So I must do it carefully. When I plug in this here, this minus into minus positive, 2a become 4a. When I plug in this here, 2 2s are 4, minus minus plus, I get a 9a. And 9 4s are 36 will cancel, and I get value of this is a 1. And wait a minute, because when we divide a into a, become a square, so a square will cancel out. So I get the value of x, a becomes 1. Okay, and let's go for next parts. First, I plug in this part equal to 0. Now I'm plugging this part equal to 0. 2a minus x equal to 0. Okay, when I plug in this equal to 0, students, what happens then? X value become positive 2a. This value I plug in the whole equation. So I'm writing here, put x is equal to 2a. Left-hand side, no change. It will remain same. When I plug in, look at here, Is this 2x minus x present here? Becomes 0. This 0. So only the middle element will stay behind. I put 0 and 0, but here I show the working. B times 2. When I plug in 2a here, 2a become 4a. When I plug in 2a here, so this 2's are 4, and out of 5, 4 gone, I got only a. And this is becoming 4, a into a square will cancel with the a square, and 4 nines. So I get an answer of B becomes a 9. Or I show you some working. 4a square into b. And which will divide down, this b value becomes 9. Okay, so this part is very clear. Now let's go for one last value. And last value, how to get it? First, I plug in this 0, done. Then plug in this 0, done. Now this 0. Third value, 5a minus 2x equal to 0. 5a is equal to 2x, or x is equal to 5 over 2 times 2a. So I'm replacing every equation, every x by 5 by 2 times 2a. Okay. Okay. So if I plug in here, no change. So 36x squared will stay as it is. A squared as it is. Now check, because I kept 5a minus 2 is 0. This gone, but it will not. It will stay behind. So 2 zeros coming here. I'm writing without any calculation. Here, when I plug in this value here in the place of x, it tends to be little fraction, so I will show working. So I get it what? 5 by 2 times 2a. Even the last part, 5 by 2 times 2a. I got these root values. I plug in here and here from here. And I believe you're understanding, students. So chance of mistakes, be careful. Okay. So here I got 2 to the 4 for 9 over 2a. 2 to the 4 out of 4, 5 gone. This negative 1 over 2a. And I get 36a squared equals to negative 9 over 4a squared times to c. And this is a square cancel. So 9 4s are 36 and 4 4 are 16. So we get a 16, but negative 16. Do it very carefully because 4 multiplies and 9 divides. Okay, Alhamdulillah Rabbil Alameen. All parts are clear. Now I copy this whole expression and I plug in the numbers because they're very important for the next part. Most probably partial fraction is helping the next parts, A, B, and C. A value is 1, so I replace 1. B value is B value is 9, so I'm replacing 9. Here minus 16. This is done. So students, this value, I take it. Okay, because he said that f of x is this one. So f of x is a whole thing is called f of x. So this is whole equal to that. So I replace these values there. You can see, students, I'm going to replace it. This. It limits what? Negative a to positive a dx. And we have answer, we need this format. And second, we has prime numbers. So P and R integers, Q and R's prime numbers. So let's see how we can do it. The formula we use normally is here, function in denominator, its derivative in the numerator, and the power of the function is 1. Answer will be logarithm of the denominator function and plus c. So this will, if I give a small example, this is 2x plus 1, its derivative is 2. So logarithm, because function down, derivative up, power is 1. So logarithm of denominator. And this whole thing will eliminate automatically. So do we have this derivative? Check. This derivative is 0 and this is 1. So ultimately 1 we have. So means function down, derivative up available. Okay. So let's see how we can do. So we've seen one thing. What I'm going to do now, first of all, I splitted them. Okay. Number two, this is a ready-made, no problem at all. But here we need something to make it. Reason, this derivative is 0, this is 1, but in the negative middle. So I need -1. Do I have -1 up available? No. What I will do, students, I will make it this situation here. I will make it 1 minus outside and 1 minus inside, because -1 into -1. So this negative will go outside and with this negative will go inside. So I'm erasing it now here and I'm showing you, wait a minute. I just show you now. -1 and -1. Actually, it's positive 9 outside. And I believe you got my point, how I produced it. Now, same story here, -16, I broken two part, 8 into 2. This derivative is 0, this differentiation -2. So -2 I need. So this 8 will go outside. So I'm writing this 8 outside. So you can do in one step even as I have done. So now students' question is ready for integration. What is this answer? Logarithm of 2a plus x with limit -a to +a. And here, logarithm of 2a minus x, limit -a to +a. And here, same story, logarithm of 5a minus 2a. Limits is -a to +a. First of all, I will plug in upper limit. If I apply upper limit, a goes here, a plus 2a become 3a. Negative of formula. When I plug in negative here, I got out of 2a negative gone, single a left. Okay. And after this, -9, this is done. And first of all, I plug in a here. When I plug in a here, students, so this is becoming 2a minus, so I got a logarithm of a minus. When I plug in negative here, negative, negative, positive, 2a plus a become 3a. Okay. Let's talk about the last situation. I plug in a here. Sorry, in the place of this x, I should write x. This is x, not 2a. Okay, when I plug in a here, I got a 5 minus 2a, I got a 3a. Okay, minus, when I plug in minus, minus, plus, and 7a. Yes, let me check again. Yes, correct. Now I have to expand it. ln 3a minus ln a, -9 ln a, and +9 ln 3a, plus 8 times to ln 3a, and 8 sevens are 56a. 56. I missed here something. I should write not like this. Logarithm of, when I plug in this value, minus is 7a, logarithm of 7a. So 8 times 2 log of 7a. Okay, students, because we have to combine them, and he said that this two form, okay, whereas p and q are integers, so integers make it separate, and prime numbers make separate. So integers. So first of all, you can see this one, 3 is a prime number, and 3 prime number, and 7 is a prime number. Whereas this 3a, okay, and I think so we can first of all, this ln 3a 9 plus 1 10. I can say, hold on, this is a 3a, 9 plus 8 17 plus 1 18, 18 times 2 logarithm of 3a. I put tick marks, this gone, and this gone. Okay. This is a 9, negative 9, negative, I got it here, negative 9 and negative, I got negative 10 logarithm of a. And further, I got negative 8 ln 7. Okay, students, 7a, sorry. Okay. After this, your student, we guess one thing. If we continue the same way, we cannot get rid of these a's. So we can get rid of a only possible if the numbers before this coefficient must same. It is only possible at this level. See, what is here 1, what is here 1. So matching, 9, 9 matching, 8, 8 matching. So better to, you can cancel there. So let's start. Before I combine them, I just divide. Logarithm of 3a by a. So this is done. Now what about this? Basic criteria, what plus 9 I write, this plus 9 I write. And logarithm of, with a plus, whatever the number will come in the numerator, and with the negative sign, what the letter will come in denominator. Done. And what about here, 8? So I got a logarithm. So with the plus sign, 3a comes in the numerator. With the negative, 7a comes in denominator. See, student, this is the only way to cancel a. Otherwise, we cannot cancel. Now I can do the same process. What has done before? 9 ln 3. Okay, and here I can expand it. I got ln 3 minus ln 7. Once again, I expand it. Okay, student, ln 3, so 9 plus 1, 10 ln 3. And here 8 multiply inside at 8 ln 3, 8 ln 7. So 8 and 10, 18. So I got 18 ln 3 and minus 8 ln 7, logarithm 7. If you look at carefully, students, what he was saying, he said that P and R are integers. Let me write P and R integers. And Q and S are prime numbers. So let's see, is this is requirement fulfill or not? So let's see, it is fulfill or not. Check R and S. Actually, R and S is, sorry, Q and S. Q and S are this and this, and both are prime numbers. R, P are outside numbers, and they are integers. So proved, not proving, you can say this is our required form. So alhamdulillah rabbil alameen, I believe the point is very, very clear. Next question, number 11. Question number 11. So what the question is saying here, students, he's saying this y and theta involved in a question, and this initial conditions given by him, and differential and find exact value of tan theta. So my target is tan theta subject. How we can convert, how can get it theta, and when y is equals to 1. So step number 1, separation of variables. So this d theta will multiply there. Done. I have to make a theta on the left-hand side. So it means theta involved here and here. So it will go there and it will come there. And I believe it is nothing hard up till now. Done. Okay, students, this is done. Switch the sides because ultimately I have to bring theta subject. So it will come, must be left-hand side. And so I am going to just bring on the other side. So 1 over 1 plus cos 2 theta d theta and equals to 1 plus y over e to power 3y dy. This is done. Now, students, if you look at carefully, it is in denominator. Okay, students. So first of all, how I can solve this one. So integrating both sides first of all. Okay. After integrating, we will try to achieve. So first of all, I will integrate both sides. But we have to do algebra also. This is splitting criteria. So I can say 1 over e to power 3y and y over e to power 3y. But here I have applied trigonometry. And what trigonometry? Basically, we have 3 rules. And I write it all 3 here. Or 2 is which are more important. Cos 2 theta is 2 cos square theta minus 1. This angle become half here. Second is 1 minus 2 sine square theta. Again, angle become half here. But you know, as I need tan has a connectivity with the secant, and secant has a connectivity with this cos. Repeat, tan, tan, if I have a secant square integration of secant square is tan, and secant is connected with the cos. So let's try, because cos in denominator. So I'm using this value here. Okay, so I hope so you understood what I given a logic, so you can understand 1 plus, and this value replaced by this. So 2 cos square theta minus 1, and 1 will cancel out, and we get a 1 over 2, and 1 over secant square cos square become a secant square theta. Okay, here I can bring it up. We're bound. This I will integrate separate, and this I will integrate separate. Okay. Gradually, we are approaching our target. Left-hand side integration of secant square, is a tan. And what is integration of this is e to power negative 3x divided by negative 3. But how we can deal this? There's a product, uv. So this is u, this is a v. So let's take a look. So what is the basic rule, uv? U copy integration of v minus a big sign of integral, bracket start, bracket ends, and again v integration. This v integration times 2 differentiation of u, which is this. A rule of, we have late, L-A-T-E, late. I am late, I stand for inverse, L for logarithm, A for algebra, T for trigonometry, and E for exponential. From top to bottom criteria, top is V, bottom is U. It means if exponential trigonometry comes, E exponential is V and trigonometry is U. Now, current situation, we have exponential and algebra. So you see algebra in that. And wait a minute, this is a dy, not dx. Okay. So I will apply the same property. Okay, let's start. U copy integration of v function minus a big sign of integral, a curly bracket starting, and again integration of v function into d over dy of u function, curly brackets ending, and big bracket ending. This big bracket due to this reason, and this curly bracket due to this reason. I think students are understanding what is going on. And now this I have to drag slightly up because I need a space to work on. Okay. So students, what is the left-hand side? Half tan theta. And this rearrange -1 over this negative shifted up. 3 remains down and power of this become positive. Again, this is integration is what you know it very well. First keep as it is divided by a power's derivative. Again, this is same copy paste e to power -3y by -3 into this derivative is what? I'm sorry, I missed dy. Okay, I think I missed dy here. Yes. Close bracket. So dy. Okay, students, game is not finished yet. Okay, so -1 over 3 e to power 3y. And what about the same story here? So negative y in the numerator and 3 e to power 3y. What about this? Negative, negative, positive, 1 by 3 outside, and here still something left behind. Okay, so let's see how we can proceed. This is a -1 over 3 e to power 3y. And -y over 3, sorry for miswriting. And what is this integration? Oh, this is a 1 over 3. This keep as it is divided by -3. And limits I will put now, same time. And sorry, plus c. Okay. And then I will put limits. Okay, student, up till here, I think idea is very clear. So, yes, all points are clear. Now I will simplify and I will shift on the next page. Half tan theta, -1 over 3 e to power 3y, -y over 3 e to power 3y, and -1 over 9 e to power 3y plus c. Okay, students, now now I'm shifting it from here and I copy paste. Okay, I'm plugging the limits. What limits given? I mean units y0 theta pi by 4. Okay, and when I plug in this value here, students, what I get answer, I will get 1 because you know tan pi by 4 is 1. So pi by 1 half comes. When I plug in 0, I get -1 over 3. When I 0 here, this full 0 because both y is zeros. When I put 0 here, I got -1 over 9. And students, after this, I will write what? Plus C. And now, okay, let me check by calculator. Half plus 1/3 minus 1/9. And C value I'm getting here. Let me check in calculator. Yeah, 17 by 18. Wait a minute. No, I type it. Okay. Yes, so value I'm getting is 17 over 18. Okay, students. Now what is the next plan? Next plan is plug in this value back in equation here. -1/3 e to power 3y, y/3 e to power 3y, and e to power 3y, plus 17 over 18. Expression done. Okay, he said find tan when y is 1. So I need to make a tan theta subject. So put y value 1. So half tan theta as it is. When I plug in 1 here, I get a -1/3 e to power 3. 1 here and 1 here, I get a 1 over e to the power 3. And 1 e 9 e to power 3. Okay, I think this is a LCM 9e cube. This copy because it's matching. This 3, not 3 into 3, I got a -3 in the numerator. And same story here. Same story here. Okay, so this is 3 here. Okay, students. So let's see how we can complete it. Half tan theta and plus 17 over 18. Okay, because he said that tan theta subject. So what is the technique, students? So this is becoming -6 and -7. So -7 I get here over 9e cube and 17 by 18, half tan theta. So this 2 will multiply both. 2 7s are 14. Over 9 e to power 3. And this 2 multiply with this 9, 2 becomes 17 over 9. 2 9s are 18. So I think this is clear, and I hope so. This is a fully done, or you can write in a little odd, different order. It's not important to write 17 by 9 before and 14 over 9 e to power 3. And this is our required target. And yes, okay. Alhamdulillah Rabbil Alameen, the concept is very clear and a lot of algebra practice required. So best of luck for exam. I hope so. Inshallah, you will do good in coming exam. So pray for me. Assalamu alaikum wa rahmatullahi wa barakatuh.